Hello and welcome. In previous lectures, we've talked about how to find if our result from a statistical test is statistically significant. In this lecture, we're going to turn our focus a little bit to discuss the difference between statistical significance and a result that has practical significance in the real world. Let's start by talking about the important relationship between statistical significance and sample size. Let's say that we have this hypothesis test set up, where our null hypothesis is that the population mean is 49.5, and our alternative hypothesis is that the mean is greater than 49.5. We take a sample and we find a sample mean of 50 and a sample standard deviation of 2. So if all of this information is held equal, if it's all the same, is the p-value from our hypothesis test going to be lower when n is 100 or when n is equal to 10,000? When we have larger samples, we're going to be able to find more precise results. So when n is larger, the p-value from our hypothesis test is going to be lower. You can see this in the equations below. We're following our standard z-score formula, where we take the observed value minus the null hypothesized value and divide that by our formula for the standard error, so the standard deviation over the square root of n. So when our sample size is 100, the standard error is 2 over the square root of 100, and when we work this equation out, we end up with a z-score of 2.5. So that's a significant p-value of 0.006, but when n is 10,000, the standard error in the denominator of this formula is 2 over the square root of 10,000. So that's an even smaller value. When we divide by a smaller value, we're going to get a larger z-score, which is going to be associated with an even smaller p-value. So when our sample size increases, our standard error is going to decrease, which means that the z-score will be higher, and high z-scores are associated with low p-values. So sample size, larger sample size, is associated with smaller p-values, more statistically significant results. To illustrate this a little further, let's say that our null hypothesis is that the population mean is 10, and our alternative hypothesis is that the mean is greater than 10, and we're going to be working with the standard deviation of 2 here. And now let's look at what happens when we have different sample sizes and some different options for sample means that we might observe. If we observe a sample mean of 10.05 when the sample size is 30, our p-value is 0.45, so not significant. When our sample mean is 10.1 and our sample mean is 30, our p-value is 0.39, so not significant. And when our sample mean is 10.2, with the smaller sample size, the p-value again is 0.29, not significant. But when we up our sample size, when we observe a sample of size 5,000, in each of these cases, a sample mean of 10.05, 10.1, and 10.2, we observe very significant p-values. So this just illustrates further that when we compare the sample statistic that we observe to our hypothesis tests, the size of the sample matters a lot. When n is large, when our samples are large, even small deviations from our null hypothesized value can have statistically significant results. So let's say that we're in a situation where we've taken a sample of size 5,000 and we observe a sample mean of 10.05 and we get this p-value of 0.04, which allows us to reject the null hypothesis that the mean is equal to 10 in favor of the alternative hypothesis that the mean is greater to 10 on the basis of observing the sample mean of 10.05. So is 10.05 a really meaningfully different quantity from 10? The answer to that question really depends on our application. It depends on what 10 and 10.05 stand for in the real world. What a difference of 0.05 means depends on what we're measuring. So if we're looking at, for example, the difference between $10 and $10.05, we can imagine in a lot of applications that might not be a substantial difference. But let's say that 10 stands for 10 billion and 10.05 stands for 10.05 billion, in which case a difference of 0.05 is a difference of 50 million. Right? So that could be really substantial. There are also lots of fields in which really minuscule differences have massive implications for what the researchers are studying. For example, if you're studying the behavior of subatomic particles, tiny differences in time of whatever you're measuring could have really substantial implications for the question that you're studying. Or lots of biometric statistics for people in health sciences are measured so precisely that really minuscule differences in those statistics could have really meaningful health implications. So, to answer the question whether 10 is meaningfully different from 10.05, we need context. So when we're talking about statistical significance, just to reiterate, what we're talking about is finding through our mathematical formulas and statistical tests that there is sufficient evidence that what we observe in our sample is meaningfully different from whatever we've hypothesized under the null hypothesis. So our value for our sample statistic is meaningfully different from our hypothesized value under the null. Real differences between that sample estimate and the null value are easier to find when we have large samples. And when we have very large samples, even tiny differences between the sample statistic and the null hypothesized value will register as statistically significant. And this is true even in cases where those tiny differences between the sample value and the null value don't have any real-world meaning. So statistical significance is something that is precisely mathematically defined. Practical significance is ultimately subjective. Whether a difference between a sample statistic and a null hypothesized value has any real-world meaning depends on the data that you're analyzing and the research question that you're asking. The job of someone doing data analysis is not only to identify whether there is a statistically significant result, but also to draw conclusions about whether the result has a practical meaning in the real world. And again, this is ultimately contextual, it's a judgment call, but it's something to keep in mind when you go out and do statistical tests of your own. So that's been a really brief discussion of the difference between statistical and practical significance. I've also assigned on our course page another video from YouTube that talks about this topic in a slightly different way, which will be a good thing for you to take a look at. Thank you for tuning in, and I will see you next time.